Good morning, children. Today we will start with a new chapter, Surface Chemistry. This chapter will be divided into 5 to 6 lectures. This is lecture 1. In this lecture, we will talk about adsorption, its difference with absorption, and etc. What is adsorption? Adsorption is defined as the deposition of molecular or ionic species into the surface. These species do not go deeper into the bulk, and get accumulated at the surface only. So you can say that adsorption is a surface phenomenon. The molecular species that get adsorbed on the surface is termed as adsorbent, and the solid surface on which the adsorption occurs, it is known as absorbent. See the figure here. In this figure, these are the molecular species that are getting adsorbed in the surface of the activated charcoal. These molecules, these gas molecules, they are known as adsorbent, and activated charcoal here is acting as the surface on which the adsorption occurs. That is known as adsorbent. The common example of adsorbents are clay, silica gel, colloids, activated charcoal. All these are the example of adsorbent where the adsorption is taking place. And the process of removal of adsorbent from the surface of adsorbent is known as desorption. Now let us see what is absorption. Absorption is a chemical or physical phenomenon in which the molecules, atoms and ions of the substance getting absorbed enter into the bulk phase of the material in which it is taken up. That means it is fully entering. Absorption is a condition in which something gets mixed or absorbed completely in another substance. It is not remaining in the surface only. It is going inside also, inside the material. Absorption is also used in context of energy passing through the medium. Part of this energy is transmitted. You can see here it is the transmitted, and part is reflected and the remaining absorbed. That is known as absorption. So the main difference between the absorption and adsorption is a surface phenomenon. It is only remaining the molecules of atoms is remaining in the surface only, on the surface only. But in case of absorption, it is entering into the bulk phase. You can see here the difference between adsorption and absorption. The first thing is that absorption is a bulk phenomenon and adsorption is a surface phenomenon. This is your adsorption. The absorbent, these are on the surface only. This is the adsorbent. It's not entering into the adsorbent. But in case of absorption, it is a bulk phenomenon. All the molecules are entering. Molecules or ions, it is entering into the bulk phase. Molecules adhere to the surface of the material, that is adsorption, and molecules are drawn into the material, that is absorption. Difference between adsorption and absorption. See here, the first one is absorption and the second one is adsorption. Substance penetrates the surface. It is a surface phenomenon. It occurs at uniform rate. For adsorption, rate increases initially, then it decreases. It is unaffected by temperature. It is affected by temperature. It is an endothermic process. It is an exothermic process. It is same throughout the material. And for adsorption, the concentration on the surface of the adsorbent is different from that in the bulk. Here are some examples of adsorption. Number 1, if a gas like oxygen, hydrogen, carbon monoxide, chlorine, ammonia, sulfur dioxide is taken in a closed vessel containing powdered charcoal, the pressure of the vessel goes down as charcoal adsorbs part of the gas. Number 2, if methylene blue is shaken with bone charcoal, the blue color of the dye disappears. Why? Because methylene blue gets adsorbed over bone charcoal. Number 3, raw sugar solution after passing over bone charcoal bed becomes colorless as the coloring material gets adsorbed over bone charcoal. Number 4, the moisture in air gets adsorbed over silica gel and the air gets dehumidified. Now, some important terms related to adsorption. The first one is adsorption. Heterogeneous phenomenon of molecules, ions or atoms getting stuck or accumulated over a solid surface. It is the phenomenon. Next is adsorbent. As you all know, the solid surface over which adsorption takes place. Next is adsorbent. The species, that is molecules or ions or atom getting stuck over the solid surface, that is known as adsorbent. Now next is absorption. Absorption is the bulk phenomenon of molecules, ions, atoms or the energy getting distributed uniformly over the medium. Next is desorption. It is the phenomenon of adsorbent molecule captured over the adsorbent surface getting released. Then it is known as desorption. And the last one is only sorption. The sorption is the phenomenon wherein both adsorption and absorption takes place simultaneously. This is also happening. Then that phenomenon is known as sorption. Mechanism of adsorption. Now, the adsorbent is made up of particles, and the interparticle forces inside the adsorbent, they balances each other. Okay, but it may not be true for the surface of the adsorbent. Maybe all the forces, all the particles forces are not balanced by each other at the surface. Like suppose this is an adsorbent. Now in that, this is the particle, this is a particle, this is a particle, this is a particle of the adsorbent. Now, this force between the two particles, it's a balanced force. This is a balanced force. This is a balanced force. But it may have the unbalanced force, that is this one, 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 and this one. This is having an unbalanced force, that is 8 in number. Okay, so number of unbalanced force in this adsorbent is 8. So it is said that all interparticle forces balance out inside the adsorbent, which is not so on the surface. Therefore, the surface possesses unbalanced or residual attractive forces. Okay, it can be positive force or negative force. So this can be this is known as attractive force, which adsorb the adsorbate particles. It is depending upon what type of particle is coming. All the particles will not get adsorbed. There should be attractive forces between the unbalanced force, which is on the surface of the adsorbent, and the charge which is coming from the adsorbate. Okay, so that the adsorbate particles will be adsorbed on the surface of the adsorbent by the unbalanced force. On increasing the surface area, now suppose you are breaking this into two parts. You are breaking it into two parts. See, you are getting this one and this one. Now you see that you are getting some new unbalanced force after breaking it. This one, the new one, is having a 12 unbalanced force. This is this one, 3, 4, 5, 6, 7, 8. Along with that, 9, 10, 11 and 12. So, increasing the unbalanced force. That means the residual attractive forces increase, and so more adsorption will take place. This is the mechanism of adsorption. I think I am clear to you. Adsorption is an exothermic process. Already it is said in the difference between adsorption and absorption. It is said that adsorption is an exothermic process, which means that energy is liberated during this process. Okay. What is that? Why adsorption is an exothermic process? Because when adsorption is taking place, that means the adsorbate molecules, they are coming and getting attracted by the adsorbent surface. Okay, that means some bond is forming. If the bond will form, it is always associated with the liberation of energy. Okay, so it is said that adsorption is an exothermic process because it will stabilize. Now, you see here the amount of heat that gets released when 1 mole of the adsorbate is adsorbed on adsorbent is known as enthalpy. The amount of heat that gets released when 1 mole of adsorbent is adsorbed on adsorbent is known as enthalpy. Now, at constant temperature and pressure, adsorption occurs spontaneously. Okay? Adsorption can be of 2-3 types. Monolayer adsorption, multilayer adsorption, chemisorption, physisorption. What are these things? Now, see this figure. This is an adsorbent. This is the adsorbent particle. Now, when the adsorbent particles are coming, suppose this one, it is getting attracted by the surface of the adsorbent. Okay, and they are forming a single layer. See, this is the single layer. This is known as monolayer adsorption. This is the first one is the case of monolayer adsorption. And you can see this one, this is getting adsorbed by the surface of the adsorbent. So it is adsorption. Now after adsorption, maybe due to some reason, it is again going away. See this one, it is going away. Arrow is in the upward direction. This is known as desorption. Desorption. Okay. Now, multilayer adsorption. Multilayer adsorption means when one layer is forming, that is the monolayer shown by the blue color, and the heat of adsorption of the first layer is comparable to the heat of condensation of the subsequent layer. Okay. Now, some more adsorbent will get attracted by the first layer molecule. This first layer, this blue color, are the molecule of the adsorbent, and the red layer is also the molecule of the adsorbent. Now, maybe the first layer of adsorbent particle is getting some type of force which is attracting the second layer also. But the second layer is not directly adsorbed by the adsorbent surface. The adsorbent surface is attracting the first layer only. And the second layer is adsorbed by the attractive force by the first layer of the adsorbent. So the blue color and the red color, they both are the similar type of molecule. Okay, they are the adsorbent. Okay. Now, you can see this one, in that the heat of adsorption of the first monolayer is much stronger than the heat of adsorption of the second and all the following layers. Okay, so this is typical for chemisorption case. Now, what is chemisorption and what is physisorption? Chemisorption and physisorption is the chemical process and the physical process. It is only denoting by the heat, how much heat is liberated. In that only it is said one is chemisorption, another is physisorption. Okay, which one will call as chemisorption? If the more heat will be liberated, then it is a case of chemisorption, and if little more, less heat is liberated, then it is known as physisorption. Okay, and there is not so much difference between the chemisorption and physisorption. Now, change in entropy during adsorption and adsorption equilibrium. In any adsorption process, delta G is equals to delta H minus T delta S, where delta G is known as free energy. You all know about it, free energy change. Delta H is the enthalpy and T is the absolute temperature, and delta S is the change in entropy. Okay, for the adsorption to be spontaneous, when we will say that the adsorption is spontaneous, when delta G should be negative. When the delta G is negative, then the adsorption is spontaneous. Since an adsorption process is exothermic, as I told you, so naturally delta H is negative. Okay. Now, due to adsorption, the adsorbent particle gets stuck to the surface and hence the entropy decreases, implying delta S to be negative. Okay, what is the meaning of that? Due to adsorption, the adsorbent particle gets stuck into the surface. So naturally the movement will be less. So entropy decreases, which implying that delta S is negative. Okay. And the formula is delta G is equals to delta H minus T delta S. And I am saying that delta S is negative. So naturally T delta S is positive. It will be positive because the formula is negative. But if I am giving the value of delta S is negative, so this T delta S will become positive. Okay, I am saying delta G, formula is delta G is equal to delta H minus T delta S. This is the formula. Now in that delta S is negative. So naturally this minus minus will make T delta S is positive. Thus for delta G to be negative, the absolute value of delta H should be more than T delta S. Absolute value. What is the meaning of absolute value? Suppose I know that delta H is negative. Okay. And I know that delta G is also negative. And then only the adsorption is said to be spontaneous. Delta G should be negative. Okay. And I know that as adsorption is an exothermic process, delta H is also negative. That I know. Okay. So the absolute value, I'm just giving you a very simple numerical value. Just numerical value. Suppose I want minus 2. Okay. It should be equal to minus 4 plus 2 because I know that T delta S is positive. So absolute value is 4. So the absolute value of delta H should be more than T delta S. I'm talking about absolute value. I'm not talking about the sign. Okay. At a point when absolute value of delta H is equals to T delta S, then delta G becomes equal to 0. And the adsorption is said to attain equilibrium. Am I clear to you? Types of adsorption. Depending upon the force with which adsorbent species are held on the adsorbent surface, two distinctly different types of adsorption have been proposed. First is physisorption and the second one is chemisorption. When force of attraction between adsorbent and adsorbent is weak Van der Waals type, They are known as physisorption. Chemisorption, when adsorbent molecules are held by adsorbent surface through strong chemical bonds. These chemical bonds may be ionic or covalent in nature. Already I told you. And as I told you, there is not so much difference. It is said that if the heat which is liberated during adsorption, if the heat liberated is approximately, I am saying approximately more than 40 kilojoule, if the heat liberated is more than 40 kilojoule, then it is said chemisorption. And the below 40 kilojoule, it is termed as physisorption. Okay, and this is also there. For physisorption, it is the force of attraction is weak van der Waals force, and for chemisorption, it is a strong chemical bond, and the chemical bond may be ionic or covalent in nature. Sometimes an adsorption may involve both physisorption and chemisorption. In such cases, it is called only sorption. Characteristics of physisorption. It lacks specificity and is multi-layer in nature. That means it is not very specific. They are having weak van der Waals force, so it can absorb any molecule. It's not specific. But for chemisorption, it is specific. Okay. Amount of adsorption depends on the nature of adsorbent. How much adsorption will take place? That is depending upon the nature of adsorbent. The extent of adsorption increases with the surface area at a given temperature and pressure. That already you have understood that if you increase the surface area, adsorption will be more, because the number of free surfaces will be more. Okay, so attractive force will be more. It can attract more adsorbent. Next, it is an exothermic process with low enthalpy. I told you, less than 40 kilojoule per mole. It is 20 to 40 kilojoule per mole. No appreciable activation energy is required. You know about the activation energy. You have learned it in chemical kinetics. So no appreciable activation energy is required. It exhibits multi-layer adsorption at elevated pressure. If you increase the pressure, then it exhibits multi-layer adsorption. Now, characteristics of chemisorption. It is specific and is mostly monolayer adsorption. As it is very specific, it is mostly monolayer adsorption. Rate of adsorption increases with increase in the surface area. It is exothermic with high enthalpy of adsorption, nearly 82 to 40 kilojoule per mole. It is first increases and then decreases with temperature. Okay, sometimes high activation energy is required. Now you can see in this slide comparison of physisorption and chemisorption. See, these are the adsorbent surface. Now in this adsorbent surface, for the first one, bound to the surface by van der Waals force, these are weak van der Waals force, and it can form multi-layer adsorbent is coming. So it is known as physical adsorption. Okay, the first layer is only attracted by the adsorbent surface, and the rest are getting the second layer and the third layer. They are coming and getting attracted by the force from the which is experienced by the first layer of the adsorbate particles only. For chemical adsorption, which is also known as chemisorption, in that it is the adsorbate, they are bound to the surface by chemical bonding and they are forming monolayer structure, monolayer adsorption. Comparison between physisorption and chemisorption. The first one given for physical adsorption and the second one is chemical adsorption. The first point, the forces operating in these cases are weak van der Waals force. And for chemical adsorption, the forces operating are chemical bonds, that is ionic or covalent bond. Number 2, the heat of adsorption is low, about 20 to 40 kilojoule per mole. For chemical adsorption, the heat of adsorption are high, about 40 to 400 kilojoule per mole. Number 3, the process is reversible. Desorption can be occurred by increasing temperature or decreasing pressure. For chemical adsorption, the process is irreversible. Efforts to free the adsorbed gas give different compounds. Okay. Number 4, it does not require any activation energy. But for chemisorption, it requires activation energy. Number 5, it takes place at the low temperature and decreases with decrease in the temperature. For chemisorption, this type of adsorption first increases with increase in temperature. Number 6, it is not specific in nature. All gases adsorbs on all solids to some extent. But for chemisorption, it is highly specific in nature, occurs only by the possibility of formation of chemical bonds. So it is very, very specific because chemical bond has to form. Okay. Number 7, it increases with the increased surface area of the adsorbent. It also increases with the increase in surface area of adsorbent. Last one, it forms multi-molecular layer and it forms unimolecular layer. Factors affecting the adsorption of gases on solids. The first one is nature of adsorbent. A gas which is adsorbate is adsorbed in different amount on different adsorbent. For example, hydrogen is an adsorbate which is strongly adsorbed on nickel but very weakly on alumina surface under identical condition. Here nickel and alumina, these two are the adsorbent. Hydrogen is an adsorbate which is adsorbed differently in nickel and alumina under identical conditions. Nature of adsorbate, that is gas, it can be gas or it can be iron. Now iron, it is coming from the liquid. Suppose any impurities are present in liquid, then these all impurities are acting as a adsorbent. Okay, they are moving as an ion only. So in that way it is said ion. Now gas or ion, nature of adsorbent. More liquefiable a gas is, more efficiently it is adsorbed. For example, ammonia, HCl, Cl2, SO2, CO2, etc. are more readily adsorbed than the gases like O2, N2, H2, etc. So it is depending upon the nature of the adsorbent also. Surface area of adsorbent. You all know that increase in surface area of the adsorbent results into greater adsorption of the adsorbent. Finely divided metal particles such as platinum, nickel, and porous substances such as charcoal, silica gel are good adsorbents. Next point is temperature. Adsorption is an exothermic process. You all know about it. Therefore, by Lee-Sattler principle, rise in temperature should bring down the adsorption. Pressure of adsorbent. Suppose the adsorbent is gas. Since adsorption of gas leads to reduction in pressure because the gas is getting adsorbed by the adsorbent, so it leads to reduction in pressure, and because of that, increase in pressure should result into increased adsorption, again by Lee-Sattler principle. And the last point is activation of adsorbent. Add-on handling of the adsorbent surface may lead to its activation, resulting into greater adsorption. These handlings includes roughening the surface, heating it, breaking it into smaller pieces to increase the surface area, including porosity into it, etc. Along with this, lecture 1 ends here. In the next lecture, we will discuss about catalysis. Now this catalysis already we have learned in detail in chapter chemical kinetics. What is relevant for this chapter, that much only will be discussed in the next lecture.